All right, let's take a look at how these transformations affect some coordinates. So I'm going to start at the top here. So my function is described as this transformation, f of x minus 7. I'm given some original coordinates, 2, -6, and I need to find the new coordinates after the transformation is performed. So this is going to be a vertical transformation. Is outside the function notation, and I'm going to subtract 7 from the original y coordinate. So the new y coordinate is going to be -13. And the x coordinate used to be 2. That is not affected by anything that we've just done. So the x coordinate stays as a 2. Okay, next transformation. This function transformation, f of x plus 2. Inside the parentheses, we've got that plus 2. And inside the parentheses is always going to have a horizontal effect. It's going to change the x coordinate. And I remember from my notes page, I always do the opposite sign. So the function notation here says x plus 2, but I actually need to subtract that 2 to get my new coordinate. So I'm going to take the 2 in the coordinates, subtract that 2 from the transformation. 2 minus 2 is 0. And the y coordinate is not affected at all, so that's going to remain as -6. Next, let's scroll a little bit so we can see this. Have a negative f of x. It's outside the function notation, so this is going to only affect the y coordinate. It's a vertical transformation, so I'm just going to take that original y coordinate of -6 and multiply it by the -1 in the function notation, and that will give me +6 as the y coordinate. Right, that x coordinate of 2, not affected at all, so it's going to remain exactly as it was. Next, f of -x. So this time I've got that negative coefficient inside the function notation parentheses. So this is going to affect the x coordinate. It's going to give it the opposite sign. I'm just going to take that 2 and the coordinates multiply by the -1 in the function notation. So my new x coordinate will be -2. The y coordinate of -6 is unaffected by what I've just done, and so it will remain unchanged as a -6. Hey, so let's look at an example of some stretches and compressions. Same directions here, give the new coordinates after the transformation indicated. So this transformation, we got 5 f of x, and of course that means multiplication. We don't always write the times. Usually we don't write the multiplication symbol, but that is 5 multiplied by the f of x. And since it is outside the function notation, I know that's going to be a vertical transformation. It will affect only the y coordinate, and y coordinate transformations pretty much you always do the face value. It says multiply by 5. I'm going to take that original y coordinate of -5 and I'm going to multiply it times 5. So it's going to give me a y coordinate of -25. The x coordinate here is totally unaffected. This transformation has nothing to do with the x coordinate, so it's going to stay 12. Next, f of 4x. So inside the parentheses, we got that 4x. I know that inside the parentheses is going to be a horizontal transformation, and it will affect the x coordinate. But this is a little bit tricky, right? So let's go back and check our notes to see anytime you can't figure out, like, I don't know what that transformation is, I don't remember, or I want to make sure I'm doing this the right way. So we're looking for f of number times x, where that number is inside the parentheses with the x. So we jump back here to our notes page, and I can see it right. This one. There it is. So we've got that number. It's called a k on the notes, but that number multiplied by x inside the parentheses. So what I'm supposed to do is take that k, and I need to get the reciprocal. So my number was 4, so I'm going to do the reciprocal of 4. That's 1/4. That is what I multiply to find my new x coordinate. So let's see what that's going to look like for us. Okay, so out of the function notation, the k number, that's my coefficient, that's 4. I need to get the reciprocal. The reciprocal of 4 is 1/4. Now I'm going to take that original x coordinate of 12, multiply it by this reciprocal, the reciprocal of the k value, and 12 times 1/4 is 12/4 or 3. That is my new x coordinate. So the transformation is going to give me an x coordinate of 3. The y coordinate this time is unaffected by this transformation. There was no other transformation that's outside the parentheses. So the y coordinate is going to stay as a -5. All right, here's an example from the WAMAP assignment. On the left side here, I've got some original graph. The graph of y equals f of x is shown. I'm going to do a transformation. So here on the right side, draw the graph of g of x equals f of x plus 2 on the graph below. Okay, so inside the parentheses, we got plus 2. Plus 2 on the inside is just like right here on our notes page. Plus some number c is going to move the graph to the left. If I wanted to think about what's going to actually happen to the coordinates, I'm going to take the original coordinate and subtract that c number out of the function notation. So I could find the coordinates of each of these 3 kind of like ends, the endpoints of each of those segments on the original graph. I could find the coordinates of those, subtract 2 from each of the x coordinates. Okay, that's one approach. I'm not asked for the actual coordinates here. I just need to make that new graph. So the first point on the original graph is at -4, 0. So in my new graph, I'm going to take that, what that point would be, except slide to the left 2 spaces, click. So there's my first point. The next point on the original graph here is at -3, 3. So if I move that left 2 spaces, it's going to be at -5, 3. It's -5, 3, click. And then the last point here on the original graph is at 3, -1. If I subtract 2 from that x coordinate, it's going to be 1, -1. Click. All right. And so the graph, it's got this like tail that follows my mouse around. It doesn't affect anything. I mean, I can see it. It doesn't affect my answer at all. So I can leave that there and just hit submit. It doesn't matter what that point is doing, whether it's doing something or not doing something. If you want it to go away so that it doesn't show up anymore, you can click on that last dot you drew again, which is a little bit tricky because if you miss, it's going to draw another dot, and then that'll be a mistake. You can also just click off of the graph, boop, and now that I have clicked off the graph, it's not going to follow my pencil around anymore. Hit submit. There we are. Here's our next example. We got y equals f of x. Is the original graph shown here. This is on the top part of the graph, and I'm asked on the next graph down below that to plot y equals f of -x. All right, so the -x, that's inside the parentheses. I want to check with my notes page, see what that looks like. Oh, here at the very, very bottom, it's the horizontal flip. I'm going to reflect horizontally across the y-axis. So I recognize that in the center column here, inside the parentheses, you got -x. That negative sign could be part of a negative coefficient. In this problem, it's not. It's just a negative sign. And so what I need to do is change the sign of all of the x coordinates. And what the effect on the graph is it's going to reflect across the y-axis. Shoop. Anything that was on the left will end up on the right. Anything that was on the right is going to end up on the left. So this first point here is at -1, 7. I'm going to change the sign of the x coordinate. So it'll be +1, 7. So on my new graph, +1, 7, click. And it says the graph's going to follow me around. So the next point on this top graph is at 4, 4. Change the x coordinate. So it'll be -4, 4, click. Next point in the little zigzaggy shape here, that's at 5, 6. Change the coordinate of the x coordinate to negative. So it's going to be -5, and positive 6, click. And then the last point here is at 6, 1, change the value of the sign of the x coordinate. So it'll be negative 6, 1, click. All right, so I've got my shape. I'm going to go ahead and click off the graph so that stops following my cursor around. And then I also need to pay attention to the dots. This graph has some dots. So I've got 2 different styles of dot. I've got a closed dot and an open dot. So this is going to help me identify which point is which when that reflection happens. Like thumb is different than pinky, right? So I want to know which one is which. So the closed dot was at the negative 1, 7. So I need to draw a dot. Closed dot is dot. I'm going to put that here at the positive 1, 7. And then at the other end at 6, 1 in the original graph, or negative 6, 1 is an open dot. So I could click open dot and it will draw that for me. Hooray!